So this session we keep on studying the mathematics. One part is more close to the statistics. This is a Poisson distribution. In fact, Poisson distribution is a kind of the binomial distribution, right? Binomial distribution. And it's based on last time we discussed a negative binomial distribution, right? This is in fact is another application and a special binomial. Okay. So what's the characteristic specialty of the Poisson distribution and how we use them? And yeah, let's go. Let's start first. Poisson random variable. What's the Poisson random variable should be meet for? What's the standard here? So they have, in fact, it's three standards. The first is we already know the expectation value mu. In a period of time, and the pool should be very big. The pool should be very big. Okay, the pool should be very big, and the successful rate should be very low. Okay, and there's one thing also need to mention is that they have proportion. So if this occurred in 1 month, should be proportion to the same probability to 1 year. So you have to meet this criteria so you can use Poisson distribution. Okay, so remember it have to be, because why I say it's binomial distribution, because it's only have two answers, right? Successful or unsuccessful. So think about that. So also below I can also show you this is what? This is exactly binomial, right? Distribution, right? So limitation nk. N is what? N is how many times, right? K is how many successful, right? Try, right? Then P is probability. 1 minus P is like either successful, either unsuccessful, right? Right? Something like that way, okay? So if you talk about this, we have another one for special one is a Bernoulli, right? Bernoulli is like either 1, either 0, either fail, either successful, right? So okay, let's keep on going to see that. So this is finally we provide. Don't ask me to prove that. Okay, why Poisson variable the proportion is like this way. Okay, they have, you can find many resources to finally calculate this one based on this one. Okay, based on this one. So when x equals to k, k times trial or k times successful equals to e to the elective mu. Mu is expectation value times mu to the kth power over k prime. Oh, here someone may not familiar with e. E is exactly equals to 2.71828. Let's not finish. They still have unlimited after that. Okay, decimal after that. And how e come? E is this one. It's limitation when n to the maximum, and the e1 plus 1 over n to the nth power. This is exactly e. Okay. So what's normally Poisson distribution used to calculation to do the statistics, especially when we do that when have like a big area or less incident happen. Normally we normally use in calculated or predicted the accident car accident or something in an area, right? So because they have so many traffic will pass by, right? So this is a big portion, but the accident is comparatively very low, right? So yeah, so that's it. So I will give several examples, 2 examples exactly. So let you know how powerful or what's the use. Where do I use this Poisson random variable? Because you may future you will encounter like exponential distribution, logarithm distribution, right? Many different kind of they have a different kind of special field to use, right? So let's see how Poisson field use that. This other example I made of myself, okay? So think about patent, of course, and not copy others. Okay, so XY cinema has an average 4.5 times lost power when projected film in a year. So I'm not sure if I experienced one time in a cinema. It's suddenly out of power when the cinema is showing. So it's very, very annoying, right? You just stay there because it's dark. You cannot go out or something. Just stay there, and you expect the power come back immediately, but who knows, right? So the more or less even happened, lose power is much better for the operation of cinema. For this cinema XY, they have a 4.5 times lose power. And then, well, my question is, what is the probability that out of power only happens 3 times a year? So let's first think about this as meet our Poisson distribution, okay? First, in a year, they have so many showing, right? Always open, right? The cinema's majority time is open, so showing so many things. So they'll have many chance to, even in every second, have a chance to lose power when showing the film. Am I right? So this is a very big pool. Okay. Second, the incidence happens is very small. Am I right? The third is it's proportional, right? So it's because it's not it's when it's happened in 1 month, it can be proportional to 1 year. You know what I mean? Give example, if 1 month happened 1 time, so 1 year probably is 12. That's called proportional, right? So since they meet all the standards, so we can use our formula. Now the formula is ask only happens 3 times a year. What's the probability, right? So look at formula here. So we need x. We need what? We need a mu, right? Mu already know is 4.5, right? X is what? Only 3 times, right? So this is, if you understand, it's quite easy. It is not like other mathematics you have to calculate a long time. This is really short time. So x equal to 3, and then this equals to what? E to the negative 4.5 power times what? 4.5 to the third power over 3 prime. Of course, I will not calculate here by myself. This supposedly you have to do it by calculator, right? Or you are a genius for calculation. So I just provide the answer that I got it. It's 0.168717, whatever. Just to keep 1, 2, 3, 4, 5, 6 after 6 decimals. Okay, so you also can write in as 16%, 87. 60%. So they have all nearly 70%, right? The chance that you only have 3 blow out of the power happens in a year. So it's very lower, right? So you can think about if only happen in 1 time, only happen in 2 time, there will be far less. I'm not sure, but it can calculate it that way. Okay, it will be, I guess, it will be very far less. Okay, so how about if over what? How about over 4.5 times? Can we calculate it? Of course we can, right? But I just leave you to think about it. Okay. Second example here. This is also another application that you can use. 9th Street is in my city, has an average 10 pedestrians walking showing on that street at what time? 12 midnight, right? 12 midnight, they have 10 person in one small street, it's natural, right? It's natural, right? It's no many people in a 1 hour, in a 1 hour, 12, right? In a 1 hour that time. The question is very funny. I ask, what's the possibility that only two people person showing on that street at the same time? Interesting, right? So let's first see if it is meet for the Poisson, right? Standard distribution standard is like 12 a.m. at that time, midnight, and they can be a very, very, very big pool. You don't know how many. You also can be less or equal to zero, right? Equal to zero, right? So you don't know. So it's a big pool, and they happen every day. So it's very, very big pool. Happen every day. It's very big pool. Aside from that, is they only have what? They only have two binomial, right? One is showing, one is not showing. Am I right? Aside from that, it's only have less occurrence. Here only two people here. Only 10 people. 10 people comparing with the pool is very smaller. So based on this one, we can use Poisson distribution, right? Poisson distribution. So they ask only two persons. So two persons is what occurrence. Of course, is x equals to 2, right? And the mu already know is 10. Am I right? So let's just follow that one. So p x equals to 2 and equals to e to the negative 10 times what? 10 to the second power, then over 2 prime. Same as last example. I will not calculate to you because I don't want to waste your time, but I already do that already. So the answer will be 0.00227 and make it 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, okay, 5. So if I make them, it's like 0.23%. Very low, right? So the result shows that if you want to see, they have only 2% at midnight showing on the ninth street. It might be happen, but the chance is even less than 1%, right? So you think about that, how useful that to um, use the Poisson distribution to, if they meet the standard, of course, if they meet the standard to calculate or prospect the proportion or possibility that we want to know, right? Right? Yeah, I think it's very useful. So I hope you really learned something in this session. Okay, thank you very much and have a nice day. Bye bye.